Bom, boa tarde, pessoal. Antes de mais nada, muito obrigado pela presença de todos. Meu nome é Gladstone, sou funcionário aqui do banco. E como vocês devem saber, a apresentação vai ser em inglês aqui do Dr. Mohan. So I'll start to speak in English from now, right? I think it's good because all of us will have the opportunity to warm up with this Brazilian English I'm talking here. Again, thank you very much for your presence. I would like to thank very much Dr. Mohan and IBM for the opportunity to have Dr. Mohan with us today. And also, também, I would like to thank our partners from the PUC Rio University. They are here with us. They will record the event and put it on the ECOA channel. It's the ECOA of PUC Rio University, where you can find so many interesting materials about many subjects, especially blockchain. I urge you to navigate until this page, ECOA, okay? Like an echo. And for you that maybe don't know well Dr. Mohan, I had a bio of Dr. Mohan, but it was 39 pages. It's very big. So I will make a very short form here. But before that, I would like to say to you that here in BNDES, we have some projects in blockchain. We are organizing some events every now and then about the subject, especially in this December 3rd, there will be a Blockchain Gov event. That's a whole day event about blockchain with a special applications for government and public interest. So it's a little broader than just government applications. So I invite you to go to the site and make your inscriptions and so on. So I'll start to read the short form of the bio of Dr. Mohan. Dr. Mohan is currently an IBM fellow at the IBM Almaden Research Center in Silicon Valley and distinguished visiting professor in Tsinghua. I don't know how to read it very well, but I did my best. Tsinghua University of China. He has been an IBM researcher for 37 years in the database and related areas, impacting numerous IBM and non-IBM products, the research and academic communities and standards, especially with his invention of the well-known Aries family of database locking and recovery algorithms, and the presumed abort distributed committed protocol. Okay, we are using Dr. Mohan in our databases, and we didn't know that. This IBM ACM and I3E fellow has also served as the IBM India chief scientist, in addition to receive the ICM Sigmoid Innovation Award, developed the 10-year Best Paper Award, not bad at all, and numerous IBM awards. Dr. Mohan was elected to the US and Indian National Academies of Engineering and named the IBM Master Inventor. A distinguished alumnus of IIT Madras, received his PhD at the University of Texas at Austin. He's an inventor of 50 patents. Good. Pretty good. He's currently focused on blockchain, big data, and HTAP technologies. For 2 years, he has been an evangelist for private blockchains and the myth-busters of public blockchain. So if you're fans of Bitcoin, I have to warn you that we're going to have a hard time here. You may know that we have a project in public blockchain, so we are very open to different positions, as you can see. I don't know, where did I stop? Okay, public blockchains. Since 2016, Mohan has been a distinguished visiting professor of China's prestigious Tsinghua University. He has served on the advisory board I3E Spectrum and on numerous conference and journal boards. Mohan is frequent speaker in North America, Europe, and Asia, and we're bringing him to America, right? And has given, South America, and has given talk in 40 countries. He is very active in social media, and I'm a witness of that. He was taking pictures as a crazy on social media and has a huge network of followers. We are included now. More information can be found on the Wikipedia. Just look at C. Mohan. The first name is unpronounceable for Brazilian. And I would like to thank you very much. Dr. Mohan, please, the stage is yours.
Thank you. Thanks for that wonderful introduction, Gladstone. And I had a great time this morning. As you can imagine from what he said just now, we were arguing like crazy about permissionless versus permissioned, or public versus private blockchain. So I had a great time meeting up with a bunch of people who are working on blockchains at Desde. So I'm very happy that you decided to host this talk. I'm also very happy that my IBM Brazil colleagues decided to have this Bluetalks at Rio meetup. I'm, of course, quite excited to be in Brazil again. This is my fourth visit, fourth time in Rio also. But the reason I came on this trip was because of a conference in Salvador, which I visited for the first time. And so I gave essentially this talk a couple of days ago at the 38th International Conference on Conceptual Modeling. So it's a sort of a database conference, but high-level database conference. Entity relationship model related stuff was presented. I'm more of a hardcore nuts and bolts database guy, low-level bits and bytes and extremely details-oriented recovery, locking, crash, and all sorts of failures and distributed databases, transaction management. So it's only in the last 3 years or so, really 3 years or so that I've been paying attention to blockchain technology and what's real, what's hype and such. But IBM, of course, has been active in this space for a bit longer. And I bring a database perspective to this whole thing, having spent enormous amount of time on hardcore database technologies. And a lot of the people who have been working in blockchain have been more distributed systems people and cryptography kind of people and so on. And they are not always worrying about performance. To give you an example, 35 years ago in the database community, we were talking about 1,000 transactions per second with sub-second response time as being the most immediate goal that time ago. So you can imagine by now, it's crazy the number of transactions per second that traditional transaction processing systems and database systems can handle. And also during the dot-com era, the response time requirements got reduced even tens of milliseconds from sub-second. And so given all that, you can imagine when I heard about 7 transactions per second and 10 minutes for a transaction's outcome to be known, I felt like throwing up in this day and age compared to 35 years ago. So that's the kind of background that I wanted to give you. In terms of what you see there, the right side QR code refers to that link that you see, where you'll find lots of material where a lot more arguments that I have carried out with even Turing Award winner like Silvio Micali, the father of Algorand at MIT, in Heidelberg Laureate Forum about a year ago. You'll find video links, as well as the left-hand side QR code is for a Sigmod, ACM Sigmod International Conference paper I had as part of a keynote I gave the first week of July in Amsterdam. That's my community. Normally I attend Sigmod, VLDB, and all these hardcore database conferences. It's only recently because of this blockchain orientation, I've been invited to all sorts of other conferences where people are gradually coming to terms with the reality of blockchains that goes far beyond the hyped up state of affairs that has existed for about 10 years with the arrival of Bitcoin and such. So I recommend that you go read that paper. It's very easy to read, no algorithms, no proofs, and no theories and all that, but it has also gazillion references to papers, which will give you a lot more information. And what you will find is that more than research kind of papers, especially in the permissioned blockchain space, there are more industry kind of papers, white papers and such things that go into the details of some of the systems that are around. I would rather see you, looking at non-esoteric papers than, I'd rather let you see non-esoteric papers rather than the esoteric papers, a gazillion of which being cranked out even as we speak by the distributed systems community, cryptography community, and so on. It's become like a cottage industry for generating what I consider to be mostly useless stuff in terms of long-term viability and practicality of what's being talked about. All sorts of weird failure scenarios are imagined and so on, and a lot of it is, in my opinion, barking up the wrong tree. So if I had all the time in the world, I'll spend the next many hours. I realize it's a Friday evening, so I really appreciate so many of you taking the time to come on a Friday afternoon. As it happens with all this, tons more people register than who show up. So I'm even more appreciative of you that has actually shown up compared to the many others who registered and haven't shown up. So the original idea behind the talk, and I started giving this variations of this talk about 2.5 years ago. My first ever talk was in Hong Kong in 2017, April. Since then, I've given variations of this talk in 13 countries. The level of interest is unbelievable, but at the same time, I'm also annoyed because I've done very little real work in this space. I'm just explaining and arguing and all that. Whereas in the database space, where I have actually done lots of hardcore work, I never got this level of importance in terms of being invited in such a short span of time to so many countries and so on. But that also says something about how sometimes the world gets too carried away with the latest buzz thing than the really important thing and such. So that's the paper I referred to before. The green things that you see there are the different permission blockchain systems that are around. Libra, of course, is a combination of permissioned and permissionless. It's a hybrid kind of system that Facebook recently cooked up with a bunch of partners, but the initial implementation is actually by Facebook people. And the full production version, they claim, will be sometime next year, and it will be done jointly by the members of the Libra Association. And gradually, the number of people who initially said they were members has come down because some of the major players have withdrawn from it. I don't know how much you guys keep track of what's happening with Libra and how much of scrutiny Zuckerberg and company have been put through by even the US Congress with respect to Libra recently. So as I'm sure all of you are aware, it all started with Bitcoin, and as I already indicated, I'm very unhappy with this performance characteristic. It also has this basic issue that I have with it, which is anyone, anywhere in the world without revealing his or her identity can willy-nilly come and go. And it's claimed to be its good property. In my opinion, it's actually a bad property. The fact that you don't know who the participants are and so on. So this leads to a lot of illegal activities. Scalability is a problem. Anyone, anywhere can look at what the heck is going on in that blockchain network. And also there is this whole notion of greed that has been created by this idea that people who are winning the battle to add a new block of transactions get rewarded with some bits in the computer, which has been called Bitcoin. It's all based on no real world connection to goods and services, unlike fiat currencies. Even if you don't have gold backing, fiat currencies today are controlled in such a way that people worry a lot about inflation, this, that, money supply, GDP, and so on. So, whereas this is just you and I as geeks thinking that we know anything at all about economics and cooking up bits in the computer and calling it money and then trying to speculate on it. So at various levels of abstraction, I can whine about this, till it's midnight here. But for whatever it's worth, it's become like a craze. And there are any number of people who have bought into this whole idea of cryptocurrency, and variations of Bitcoin have come about. And we can talk about all that. But in general, there are various groups of people, little companies, big companies, entities like this bank, non-profits, profits, and such, as well as IBMs of the world and so on, are all working on different aspects of these blockchain systems. But in my mind, really, what is worthwhile is taking the underlying data structure of that permissionless one, which is the blockchain data structure, and certain ideas that go with it, and then applying it in the context of a specific business process or a workflow where a group of people who have some real world relationships amongst themselves and who have a reason to work together benefiting from this technology compared to the same sort of thing being done using traditional business processes and workflow management systems, database systems, and TP monitors and so on. And that the difference being that in the case of the permission blockchain network, you will be allowed to participate in a particular network only if you have a business reason to be part of it. And the price of admission is that you need to reveal your identity, and so if you misbehave, you can be held responsible and you can get booted out of the system and so on. So in that sense, as a consequence, the hoopla that's made in the permissionless one about Byzantine behavior and people colluding and this and that because you don't know who the heck they are, the bending over backwards to deal with that gory scenario that everybody dreams up in that context is not as much of a problem. Yeah, people can try to cheat even here, but they know very well that sooner than later, the fact that they cheated will get found out and they'll get punished, they'll get booted off the network and so on. So this is no different from you are going and renting an Uber car where you do know who the person is because Uber tells you before the driver shows up, what the car number is and what the name of the person is and so on. And also Uber has tons more information about that driver and that car and so on based on the past track record of that person. So yeah, there are still sometimes these guys try to get away with murder literally, and then of course they get reported to the police and so on. Whereas in the first one, you ask for trouble by letting people whose antecedents you don't know anything about to anonymously participate, and then you say, oh shucks, what do I do if these people all collude and try to cheat me and so on. So you then go through this painful thing called the proof of work, where you make the person who wants to add a block of transactions, solve a math problem, waste a whole lot of energy in this day and age, and then as reward for them wasting all that energy, like a dog does a trick and you throw a few biscuits at it, a few bitcoins get thrown to the guy who wins. And more importantly, multiple people can win that battle. So guess what? You add a bunch of blocks in a linear chain, suddenly all hell breaks loose because more than one guy wins the battle to add a new block. So you had 1 to n minus 1 blocks nicely in a linear fashion. Now you have n prime and n double prime. These are alternate versions because 2 guys won the battle. So now this creates this alternate chain. And then they say, oh shucks, what do I do now? Which chain should I consider amongst these alternates to be the winner? So let's wait for a while and incentivize people to add more blocks to the longer chain. And then after a while of doing all this gimmickry, we'll declare asymptotically that the longest chains people are the ones who will win. This is the kind of nonsense that leads to terrible performance and such. And it's still not 100% guaranteed that just because something was in the longest chain that will necessarily ultimately be thought of as actually the chain that won. So there's a lot of uncertainty, non-determinism about the top one. Whereas in the bottom one, by definition, at least in the systems I know of, they don't permit such alternate paths to appear in the blockchain. By definition, they make it deterministic and make only one guy at any given time be able to add to the chain, and hence it stays linear. And amongst other things, of course, that's this notion of forking, by the way. And fork also has another connotation, which I won't get into here. But the other thing is that the greedy behavior that people exhibit over there, because this notion of fee being offered for a transaction to be executed, and people try to game the system by arbitrarily choosing fees, and then the guy who adds new transactions tries to maximize his money making by picking transactions for which the fee offered is higher and so on. All this leads to all sorts of weird behavior. This is not the kind of thing we have done in traditional transaction processing. So why should we suddenly in this world think differently? Traditionally, we've had priority-based scheduling of transactions and so on in TP monitors and app servers and such. And then you get charged for the actual resources you use by chargeback mechanisms, where monitoring of the systems based on user ID and all that causes accounting to be done, and then your budget gets decremented and so on. Whereas here, in the case of Ethereum, for example, they introduce a notion of gas and this and that, and it's all an estimate, it's not actual amount of money and so on. So there are different aspects to all this that I can spend many hours discussing, which make that whole permissionless way of doing business so different from anything that's been going on in the world. with respect to transactions and such. Yeah, there are games and all that with auctions in the real world that has no connection to this kind of thing. But in my opinion, those sorts of things which mess up the system in various ways are also typically not there in the case of permissioned blockchain system, which also I like. And also performance-wise, because only the people who have reason to be part of the network will be allowed to be part of the network, and not just because somebody sitting in China or India has nothing else to do and they have a lot of energy to waste. They get involved in this validation and mining and all this nonsense that goes on, where even special purpose hardware has been invented to do this kind of thing. You don't have all that here. So you have much better control over also who gets to see what. So in this day and age of information security and need to know being important as to when somebody can see something, like GDPR and all the different kinds of restrictions on cross-border data flow and such, those things are much better handled in this fashion because nobody else that's not part of the network can look into what's going on in that network. Of course, you can have auditors and so on, but they're also explicitly permitted to become part of the network to be exposed to the different transactions and such. So from that perspective also, even from a security perspective, there's a lot more to be said that's good about permission blockchains than permissionless. So what are we talking about in a general sense? What kind of use cases are we thinking of? I'm very sorry because of some problems with the projector, this, that, and my laptop. This thing is not looking as good as normally it will look. The resolution, when I reduced and all that, it still didn't help. So maybe there's a frequency problem. So essentially, you have a group of entities that are working together. By the way, this is not only for enterprise. Sometimes people think permission blockchains are only applicable to the enterprise context, but in the context of you and me as individuals, this doesn't apply. Permissionless is the only way to go, and I disagree with that kind of assertions completely. You can have in this kind of a network nodes which represent organizations, and the people that are attached to the nodes, the end users, whatever you want to call them, the clients, they are like you and me kind of human beings playing different roles. You can even think of a farmer somewhere out there who doesn't have the wherewithal to have a node and hence be a full participant, could actually join hands with other farmers, just like it's been done with cooperatives, and even little banks in Germany used to join together in the good old days when there was no notion of cloud and such. They couldn't, each of these little banks couldn't afford to have its own IT operation, so they collectively formed a cooperative, and then some of these services were provided by that entity, which was the cooperative. So such things can be the nodes here, and the individual banks or human beings who are individuals could be the clients. So in that sense, I disagree that the permissionless one is completely peer-to-peer with no notion of node versus client and so on. That is, to some extent, in my opinion, arbitrary. In any case, what are these people doing? This group of people are managing certain assets. The assets could be purely digital assets, music recordings, videos, and so on, or they could be managing the digital version of the data that's associated with physical goods like diamonds and packages and food ingredients and car components and so on, right? And so what are the blockchain transactions doing in such an environment? They are causing either state changes that reflect physical changes to the objects, the fact that a diamond got mined and then it got polished, or they could represent or transfer of ownership. The collection of diamonds got sold in bulk to a retailer, right? So it's those sorts of state changes that are represented in the state database that are affected by the blockchain transactions, or you can just think of them as transactions that get executed here. I mean, this is not too different from what has been going on with business process systems and workflow management systems and so on. Even things like insurance claims and loan applications and such things, both in the financial world as well as non-financial kind of world. There are any number of things like this that have gone on. So the only difference is how you're going to do all this in the blockchain way compared to the traditional way. So let's, and also the way this is all done is more methodical than the ad hoc ways in which things are being done. For instance, if you look at the left-hand side, if you look at an import-export scenario, today, there are gazillion participants. Each one of them has its own state database and programs that manipulate the state database. The different nodes have their own set of databases and application programs, packages, whatever they are using. There is no single source of truth. So it's a more chaotic kind of world. They all might be using computers and exchanging electronic messages, but they tend to be point-to-point kind of messages, EDI, XML, whatever your favorite thing is. And there are still a lot of paper documents. Even if they think they have digitized it, the paper documents get scanned and put into the database. They are not digitally understandable, processable, in the sense of, really understanding the characters within the digital image and so on. And so this leads to a lot of inefficiency. Money gets tied up in the, path that's taken by the physical goods or whatever, or the information that gets passed around. And also there is likelihood of some people doing some bad things in the sense of, let's say that food was being transported in a truck and the air conditioner in the truck broke, the weather was bad, and the food got spoiled. Some people died as a result of this messed up food being consumed. Then people might, after the fact, change the recording of the temperature in the truck to pretend that the air conditioner didn't actually break. And the modification that was done illegally would not be easily detectable because they're all being done in ad hoc ways, and there isn't the kind of data structure mechanisms that have been built into the blockchain, for example, in Bitcoin, like hashing and all that kind of thing, that will make it possible for you to detect that after some information got recorded, it got illegally tampered with. So it's those sorts of issues that are better handled in the blockchain way of doing business, where what are we doing now? Instead of this chaotic set of programs and database systems that are individually managed by the different organizations, you now have a more methodical way in which the collection of programs are jointly developed, the so-called smart contracts, which codify the rules of engagement amongst all these different participants, and they then have replicated versions of the same database in all the nodes. So this is what is a big deal thing beyond all this cryptocurrency and all this other stuff that everybody, that's wanting to make a quick buck talks about and gets all excited about. What is the current price of Bitcoin? Oh, it's gone up, it's gone down, all this nonsense. Whereas here, we bring more orderliness to the chaotic way in which things are done over there. And as a consequence, things can be far more efficient. There is more tracking of information, the provenance of goods and what all paths they took and things like that. And as a consequence of also leveraging private key, public key, and the cryptography technologies like this hashing and so on, Merkle trees and such, you will be able to more easily identify any illegal tampering and such things. This is not the same as the kind of craziness that people worry about in permissionless systems where, since you don't know the identity, you don't even have any idea of how much to trust a particular address which represents supposedly a human being, and multiple addresses could actually be owned by the same individual, and all this kind of craziness that goes on in permissionless space. So it's because of all this that, in my opinion, and in the opinion of a lot of people who are in the real world, as opposed to, doing like gambling kind of things that people that indulge in cryptocurrencies do, this is the value prop that's going to have long-term value and which has actually been relied on by a number of organizations. And there are now, as I summarize here, lots of production deployments of permission blockchains, not just kicking the tires and proof of concept and so on. And so the way I characterize the state of the world right now is that, think of 35 years ago, some of you are younger than that, I realize, but the older ones in the audience will know. Around 35 years ago is when DB2, Oracle, and all that came out, Sybase maybe. So a bunch of relational database systems had come out, but if you wanted to use them, you are on your own pretty much with respect to when to use what feature, how these different systems compare with respect to performance and things like that. They had certain number of features, but at least the good thing there was they had the same underlying conceptual model, which is the relational model that my colleague Ted Cord in my lab had developed, the guy who won the Turing Award for Nobel Prize for Computer Science for relational model. And my other colleagues, this is all stuff that happened before I joined IBM 38 years ago in the San Jose Research Lab. This is the birthplace of relational databases and SQL. So those guys at least had the success of selling the idea of relational model to the world. So even though in my lab there was a project called System R, which was the context in which SQL got developed, at the same time there was a competing project in UC Berkeley, University of California at Berkeley, where Stonebreaker and other people, Stonebreaker more recently got the Turing Award in 2014 or so. He and his colleagues came up with a language called Quell. So the underlying conceptual model was the same for their system in US, and our system, System R, but the APIs were different. Ours was SQL and theirs was, this is why I hate having this microphone in my hand. I much prefer collar microphones. They didn't have it here, so. They had Quell as a language, but at least the underlying conceptual model was the same. Why am I elaborating on all this? Because with the permissioned blockchain systems, neither the APIs are the same, nor is even the underlying conceptual model. So there is that level of chaos. The only good news here is that because bulk of the work almost all the work that I know of in a serious way that's been done in the permission blockchain arena has been done by a group of organizations getting together in the form of consortia. The number of consortia is a lot less than in comparison to NoSQL, big data, and such places where 3 guys in 3 different garages across the globe get together and put out yet another variation on NoSQL with its own API and all this nonsense, which has caused enormous grief. When some people thought this was like, great leap forward for mankind, in the case of guys like me who have been around for a bit, in many ways, they were giant leaps backwards for mankind compared to relational and all the things that had gone on. They had some good reasons for certain things to be done, but that's the whole en masse way in which many people have embraced NoSQL when they had no business doing that is all the negative things associated with, because it's highly non-standardized and Mickey Mouse kinds of systems compared to the far powerful relational with query optimization and so on. This is true of MapReduce also from the time it came out until all sorts of things that were initially considered unnecessary got put back in. And of course, this is like, putting patch after patch and so on. So my point here is, yeah, it would have been nice if there had been a standard conceptual model. It would have been nice if there's a standard set of APIs. There are people working on trying to get that. But in the meantime, if you want to choose a system, you better do your homework well, because as it's bound to happen, there'll be a shakeout in the market. So some of the systems that are around will disappear. And if you make the wrong choice now, later, if your system of choice is not any more popular or it's just disappeared, you would have the monkey on your back to either rewrite your application to make use of one of the other ones, because now the APIs are different, so you would have to really rewrite. Or if you had the wherewithal and the system you chose happened to be an open source one, then you now have to maintain and enhance and fix bugs and all that in that open source system. And this is not for the faint of heart. So that's a lot of investment that you'd have to make. So in that sense, I tell people, you study more carefully and don't go by, oh, JP Morgan is involved in this, so I should just pick this system rather than that. Guess what? The JP Morgans of the world actually are hedging their bets by keeping their feet in multiple camps. While JP Morgan did Quorum, for example, Enterprise Ethereum, guess what? They're also members of the Hyperledger Consortium. So you really have to do more careful homework than their very surface level comparison and so on. So the good news is that there is now a new class of software called blockchain as a service offering, and that's come from many vendors. And it turns out the most popular one that all of these guys support is the Hyperledger Fabric. They might also, in addition to Hyperledger Fabric, support something else, like Ethereum or Quorum or whatever, but the one that everybody supports is, at this point, Fabric, okay? And also it's the case that relative to the relational story I gave you, where, for instance, in the last 35 years, since the original systems came out, tons of stuff has happened in terms of features that got introduced, like stored procedures, triggers, and so on, referential integrity, and so on, as well as all sorts of tools that make the life of the DBA and the system admin and all that a lot easier. So as you can imagine, similar kinds of developments are yet to happen in the case of the permission blockchains. And so there is scope for whoever you are, student, entrepreneur, big company person, and so on. There's scope for lots of new things to be done and money to be made and so on, doing useful stuff than just sitting there and selling and buying Bitcoins and all these other things. So, but it's also the case that compared to relational systems, the speed at which new things have happened, literally in the last 3-4 years, in the permission blockchain area is phenomenal. And so that also means that if you choose one version of the system, you might find that soon after another version of the system has come out and things like that. So you have to be pretty nimble if you want to leverage the newer functionality and so on. And so sometimes people don't like this in the enterprise context. Some people will say, hey, don't release too often new versions of the product, because of course we all as consumers of smartphones and so on know that every other week a new version of this and that comes out in the app space. But here also, the other good news is that it took a while for the Transaction Processing Council to be formed and benchmarks to be developed, like the TPC, BEC, and so on, in the database space. Similar things have barely started now. And even standardization efforts by ISO, IEEE, and W3C and such have made very little progress, but there are attempts to do that. And meanwhile, the database vendors are also trying to, in the context of traditional database systems, introduce certain features into them to make them do things in a quote-unquote blockchain way, as opposed to having to use some higher level middleware like a permission blockchain system like Fabric or Sawtooth or Quorum or so on. So those are, I'll mention some of them. The Chinese companies are also fairly active here, although the Western world tends to ignore paying attention to them. And of course, in due course of time, you might discover that they have an upper hand and things like that. So this just gives you a bunch of points about different significant events that have happened in the blockchain, permission blockchain space. To my knowledge, the first production deployment that happened with permission blockchain was the deployment in the context of private equity funds management using Hyperledger Fabric 0.6 release that was housed in the Guernsey Island. Since then, many developments have happened. So in particular, in the database context, Amazon announced something called the Quantum Leap database. And even more recently, Oracle has announced a new type of table called the blockchain table. These things are, to my knowledge, not yet actually released. They made announcements. And of course, IBM announced a blockchain as a service offering quite a while before Oracle's one became available. And there are others also, as I said. And even the Chinese companies formed a consortium, and they've defined a different system. But like I said before, in the case of many of these sorts of systems and the associated consortia that develop these things, some of the companies out there are actually members of multiple of these consortia. Even some of these Chinese companies, they're also part of the Hyperledger consortium while forming their own thing and doing something. So in other words, be careful, because even the companies that are doing the actual development are hedging their bets by working on multiple systems simultaneously. I suppose it's not too different from IBM at one point having DB2, Informix, and Cloudscape and such relational database systems. Do I want to say? So there is also a benchmarking project called Caliper that's part of the Hyperledger Consortium, and there are other university efforts in National University of Singapore and so on. So this is just proof of the claim I made that everybody that's put out a blockchain as a service offering, managed service, is supporting Hyperledger Fabric. This is just showing you there are lots of research projects in Europe, for instance, as well as in other places, but the European Union is funding a lot of projects. This is now summarizing many of the points I've already made, so I won't dwell on them. Like I say over there, if you are into gambling, be my guest and consider playing with these cryptocurrencies. But if you're serious about really getting real work done and so on, and by the way, the same sort of nonsense has gone on even with NoSQL and Hadoop and such, Cloudera and such companies that bet their whole business in developing Hadoop, even went public without making a profit, and then there has been mergers and their stock values went down and things like that. I say work on stuff that has the potential to make money, even though a lot of these things are being done in open source. Ultimately, we are not in the charity business. We all, commercial entities, have to make money. So beyond a certain point, getting too carried away with open source, while it might be beneficial to the people who want to use it, everything for free, for the people who really need to survive long enough to make things happen, at some point they have to make money. And so there is a careful balance that you have to do between giving away something for free versus having a version of the software with or without support that makes money. Otherwise, it's not a viable long-term proposition. And it's also the case that people will make some vague statements, and we had all these discussions this morning. I don't know if I should go around repeating all this. People say, we are providing trust in a completely trustless environment in the case of permissionless. A lot of that is bogus claims, because really, they will say things like, in the permissioned one, it's highly centralized, somebody controls it, blah, blah, blah. I'm like, in the peer-to-peer world, do you really think people send smoke signals to communicate with one another? They still use telecom networks and all that. How many telecom vendors are there? And so if you really begin to drill into such things, it's meaningless to talk about some Joe Blow in one city talking to Joe Blow in another city, and that's not, in the way of anybody else coming and screwing up that communication and so on. So also this whole business of, techie people thinking they know anything about at all about economics, and who's this guy who wrote that paper that said upfront only this many bitcoins can be there? The Satoshi Nakamoto. And what's the basis for that? I have no idea. And also, in the case of Bitcoin, what did it do really? It only worried about if I send Gladstone 5 Bitcoins, that I in fact had 5 Bitcoins to send, and I didn't send the same 5 Bitcoins to Matthias also. The double spend and the fact that I'm not cooking up money on my own, although the network is actually cooking up money with no real basis. But anyway, that's a separate discussion. They didn't do anything else. Because why am I sending money to Gladstone? Presumably because he did something for me, produced some goods or provided some services. They don't bother modeling that aspect and whether that was delivered as promised and so on. So this unbelievable focus only on the money transfer in that UTXO model is, in my opinion, such naivete to the core, even though, as I said, there are a gazillion people across the globe. It's like religious fervor for some of these people. When you go to some of these conferences, it's like you've become part of some religion and they all say hallelujah and that the whole world is going to be a better place, blah, blah, blah. And, this is like that guy who brought a bunch of people to somewhere in Central America and they all committed suicide. I forget the name of that guy. So I'm like, give me some, better sense and all that about all this. So there is also this whole notion of the the permissionless guys keep talking about validation being performed by some random guy, the guy that does this proof of work and so on. I'm like, how can this random guy sitting somewhere else validate whether or not I was happy with the service that Gladstone provided me, because of which I'm going to be paying him money? It's really such a personal thing. It's not algorithmically computable whether he was satisfied with my work or the other way around. And also, if information enters the system, the so-called oracle thing that some people have cooked up, if today's temperature in this place at this moment is being recorded, how can some guy sitting in China validate whether that's the actual temperature or it's some cooked up number? So my bottom line is, a certain level of trust is important, and you do need to have a way to, if people don't behave as they should have, and you discover that after the fact, you should have the ability to go after them and get them punished appropriately by appealing to the laws of the land and courts and such systems. And for you to be able to do all that, the identity of the person is important. So whichever way you look at it, you do need identity and such. In any case, cash transactions beyond a certain point are not permitted. So there are various good reasons in order to avoid terrorism and corruption and this and that. It's extremely important to, as long as one is interested only in supporting legal activities, to really focus more on the permissioned one. So even a Nobel laureate in economics, he has said, this whole crypto thing has put the world back by 300 years. It's not like people haven't had their own currency and all that, right? Mickey Mouse kingdoms and principalities in Europe, India, China, all sorts of places have had their own currencies. Over the decades, the world has evolved to fiat currencies, and in the case of Europe, even multiple countries getting together and forming a currency called euro was all for a good reason. It's not like they were stupid, and suddenly this guy comes up and says, oh, I'm going to replace all fiat currencies with this one thing called bitcoins. Ha, ha, ha. This is like linguistic problems can be avoided by everybody adopting Esperanto, and we know that didn't fly. And by the same token now, there are other cryptocurrencies that have come up. So even there is proliferation. It's not like this original vision that some people had, that all the problems with fiat currencies can be eliminated. Countries manipulating the value. China has been accused of such things and so on. Guess what? There's even more manipulation going on and speculation going on with cryptocurrencies than things that have happened with fiat currencies. So there's also all this other cheating and such that have happened. And then you have this whole thing about, oh, it's all completely peer-to-peer. You have your wallet and so on. Guess what? People thought, oh my God, if I lose my private key, I'm screwed. It's as good as losing a real wallet with the real cash. So what do? They actually don't manage it themselves. They put it in an exchange. And guess what? So much for all this claim that you eliminated middlemen, blah, blah, blah. Exchange is a euphemism for banks. And guess what? One guy disappeared with the private key because he died. And his family claims that he didn't even reveal the key of this exchange to this family. And so much, all this other claim, completely distributed, blah, 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 goes up in flames with this kind of thing. And then even this whole notion that, oh, because it's open source, this, that, we can completely trust everything that's going on in terms of the implementation. It's like this hallelujah thing where nobody makes a bug error and coding and no bugs are there in the world and so on. These guys claim that this bug that they had in Zcash, which has all this notion of zero-knowledge proof and so on, was found a while before, and only 4 guys in the company were aware of it, and they kept this hush-hush. And then 9 months it took for them to fix this thing, and they now claim that nobody took advantage of it, but in terms of people who know that stuff, apparently it's not even provable because of the zero-knowledge proof basis of this whole thing. So that could have resulted in double spend and past being rewritten and so on. So much for this immutability of blockchain and such. So in my opinion, all the tall claims that have been made haven't withstood the test of time. So you might wonder, where did all this Bitcoin stuff come from? Is it like this one fictitious person or group of people with that pseudonym Satoshi Nakamoto who came up with it and from scratch. No, it turns out lots of ideas from the past are being combined in interesting ways with some new ideas, obviously. And so from the early 80s, various things that have been there have been combined. And so this paper, if you're interested in the geeky details, gives you this historical perspective of what ideas from where got combined and so on. So if you're a more technically oriented person, research, whatever, in the distributed system space, there are many things that have happened over at least my lifetime, professional lifetime of 38 years, that have a bearing on what's going on in the blockchain space. And so are different topics from the database area that have a bearing. I've highlighted and read some of the things that have even more bearing than the other things. And I myself have worked on things like workflow management, business process management. A while ago in the 90s, I had a project called Exotica, working with IBM Flowmark and MQ series workflow and such things. And also in the case of replicated databases and distributed databases, my first project in IBM was an R-star project, which was a distributed database version of System R. So when I say some of these things, it's not like I'm being flippant. I've had enough of a track record in terms of looking at different highly research-oriented ideas as well as very practical systems and such, not just IBM products and prototypes, but even other companies and so on, as well as university research prototypes. And so many of the things that I've listed here, including warehousing versus OLTP system and such, are all coming back in a big way in the context of blockchains also. How do you do analytics on the blockchain data, the current data as well as the past data and such, which all have a bearing on this HTAP acronym that was mentioned by Gladstone during the intro. It's hybrid transactional and analytic processing. Instead of having one system where you do OLTP and then periodically move the data to the warehouse and doing analytics over there, which by definition means it's out of date. We want to now, currently the favorite thing is to, in a single system, do both OLAP and OLTP and provide analytics on the latest state of affairs. So the kinds of things that happened like in the 2007-2008 disaster, financial disaster, can be minimized, where during the daytime, different traders and such made decisions based on last night's state of affairs. So simultaneously, multiple people wound up committing more money than they should have in a collective fashion. So all of those things, as well as some of the things that have come up as more recent things because of the cloud and transporter data flow restrictions and such, are also having a bearing on how exactly you go about doing some of the things that go on in the blockchain space. So this is a little more detail on a particular system and approach that I know a lot more about just because I've done a project involving this, which is the Hyperledger Fabric, where you have a state database. This is the one where I said in a replicated way, we are tracking the states of the assets we are managing, packages, whatever, right? You could even implement cryptocurrencies if you want on top, but it doesn't come with built-in cryptocurrency, nor does it have the notion of gas and fees and such that are made a big deal about by the community of people that are the aficionados of Bitcoin and Ethereum and such. And this is the blockchain data structure. This is the one where I said in the permissionless one, you might have sometimes alternatives, 3' and 3" because multiple people won the battle to add a new block of transactions. So the way this thing is structured, which describes the different transactions that have been executed, not all of them necessarily successfully, but some of them might have lost out, looks like a transaction recovery log that is typically also in the state database, whatever the database system is, whether it's DB2 or LevelDB or CouchDB or whatever, right? But the information content is different, and the way this is managed is also different in the sense of when 3 points to 2, it's not merely a pointer, it also says 2's hash value is this, so that if somebody illegally later on modifies 2 and the hash of that modified version doesn't match what 3 says should be the hash value, then you can detect things like tampering of the information. And there are many other things one can talk about. But the point of all this is the way in which transactions get added, when they get added, how the different nodes that are participating in such a transaction do their operations against similar things is where the approach taken by Hyperledger Fabric is different from traditional database systems and how replicated data gets managed in traditional systems. And also, with respect to other permissioned blockchain systems, they do things differently. And even the Hyperledger Fabric, between 0.6 release, so there was 0.5 first, 0.6, and then 1.2. Between 0.6 and 1.0, there was a major change in the conceptual model and the way the transactions get executed that hopefully I'll have a bit of time to talk about. Oh my God, I hate this. So when an application or a client starts a blockchain transaction, that's like in a traditional database system, an application program invoking a stored procedure, let's say, on the server side. Here, the stored procedure you can think of as the smart contract. While that smart contract is executing, it can emit events to say that smart contract started or the blockchain transaction started. And that smart contract itself might invoke other smart contracts. This is like a stored procedure invoking another stored procedure. And also it makes database calls. Why is it making the database calls? Because it's trying to manipulate, as I said before, blockchain transactions are making state changes to the assets being managed, either to change ownership or to change the state of the asset, meaning a diamond going from a rough state to a polished state and things like that. And in order to do that, it has to retrieve information about the assets, and then it wants to then change the states, make changes to the states. So the way it works in Fabric, in the initial stage of attempting to execute a transaction, it's a pure simulation. So what that means is that the reads will be performed from the database, but the writes that are going to be performed, because it's using a very simple-minded data modeling functionality in the form of key value store, the get is the equivalent of, if you like, your SQL select, and the IUD statements, insert, update, delete statements, effectively are much simpler here, but it's also, as a result, bad. Put and delete. So the put and delete are not immediately sent to the database system. Instead, they are trapped by the layer of the fabric that sits between the smart contract and the database system. So you effectively are simulating the execution and figuring out what objects are being retrieved, which states of such objects, because over time the states change for the same object, right? And you are also figuring out what the intended updates are without actually performing the updates permanently in the database. So why is all this song and dance being performed? Because when a transaction is being simulated, the guy who submits the transaction actually sends it to multiple people, so-called endorsing peers. Why? It's somewhat like the priest asking, in the case of a marriage, the bride, are you willing to marry this other person? And asking the groom, are you willing to marry the other person? It's trying to get an agreement on the state change which is about to be performed. And each of these parties simulates the transaction, and whatever logic they are using to make their decision, they give back the result of that thinking, if you like, the endorsement, by sending back reads and write sets. This guy then compares them, and under certain conditions, which are not so important at this point to get into, but effectively these are all application level decisions. The system itself gives you various ways of expressing certain properties that you want, but what you choose to do, like even how many parties you contact during the simulation phase, is left up to you as an exercise for the use case developer. If things look good, then it says, okay, now I want to proceed forward with trying to get this transaction done. What does it do? It packages up all this read and write sets and the signatures from the people who did this endorsement. And this is where the way in which it's being done is different from a traditional workflow system or business process system, because now you are leveraging private key, public key, and all this kind of stuff, and signatures which are unforgeable and which can be verified and things like that. And sends all that stuff to this ordering service. Yeah, now you'll jump up and down, some of you, oh, it's all being done in a centralized way, bad, blah, blah, blah. it's not as bad as it all sometimes is made out to be. This guy is just an algorithm. All he does is nothing to do with trying to maximize, minimize this, that. He just literally orders these transactions pretty randomly in a serial fashion because it's listening and getting many such transactions that have been simulated in parallel by various clients, and it now lines them up in a new block. Pretty mundane thing goes on there. There's no attempt to, screw anybody and such, because there's literally no examination of the read and write sets, even though they are there. For all you know, you can encrypt it, and he doesn't care because he doesn't take advantage of it in any way. And then now he sends the newly created block to all the nodes. Not only the nodes that originally simulated, but all the other endorsing peers, as well as there are some of these guys who are purely what are called committing peers, which the distinction being the endorsing peers have the smart contracts installed in them, so they know the logic behind endorsement, the one that results in read and write sets being produced, whereas this guy, he gets involved only in the last phase. So he's merely tracking state changes for committed transactions as they happen. You might say, why do you need such guys? Maybe they are being used to do analytics. They are being used to trigger back-end processing. An order might be accepted through the blockchain way of doing business, but the fulfillment of the order might involve going to SAP or whatever that are specific to one of the nodes, and that processing is triggered by having triggers from here, for instance. Now, what do these guys do when they receive these a new block? They go through the transactions one at a time. They make sure that it all looks kosher, that the signatures are there, and so on. For each transaction, they pull up the read set, they peep into their local state database and see whether for the objects that are mentioned in the read set, is the state still the same? Meaning, from the time the simulation was done to now, has anything changed for those objects? If nothing has changed, this is the so-called validation phase of optimistic concurrency control, they then say, since nothing has changed, if that's the case, it's okay to now take the write set that was already computed during simulation and just dump it into the database. So this is a successful execution of a transaction. If anything has changed, then they can't figure out what to do other than just saying, sorry, this transaction is a loser guy. And that's no different from in traditional transaction processing. A transaction might get blown away for any number of reasons, like it got into a deadlock and it got chosen as a victim, or the system crashed, or the application logic said, if I proceed forward with this transaction, some referential constraint or integrity constraint might be violated, and so I'm going to kick it out. A unique key violation might happen and things like that. Presumably, this transaction will get resubmitted and so on, but that's outside of the system, we don't care. So that's all that's going on here. So the important point is that this parallel simulation and then serial validation and possible commitment that happens at the end could result in some transactions getting blown away, because while they executed in parallel, they all saw the same state, but by the time this validation happens, it happens in a serial way. Some of the earlier transactions succeeding during that third phase might result in the states seen by the subsequent transactions during simulation getting changed. And so they will, as a result, get blown away. So this is inefficient from that perspective, but compared to, for instance, primary copy replication and so on in traditional transaction systems, some of you that are into distributed systems should know about those sorts of things. But what is special about this way of doing business is the fact that there is this notion of endorsement where multiple parties' agreement is checked for before you go forward with the transaction. Whereas in a primary copy algorithm, the first node, the primary copy gets to decide whether a transaction happens or not. There isn't this business of song and dance discussion with the affected parties and getting their agreement and so on. So that's what's different about the blockchain way of doing business compared to traditional transactions and replicated data and so on. So, but this way of doing business has its own complications. If you're interested, we can discuss it outside. But essentially, because, as I said, this very simple-minded API is being supported for modeling your assets and so on, life is not so hard to detect what the read set is and what the write set is. But I'm not at all happy with the fact that it's a simple-minded API. As I commented about NoSQL being, in many ways, a backward step for mankind, for people who are used to using the more powerful relational way of modeling assets and less error-prone and not too dependent on application programmers not screwing up and such. Once you replace this get, put, delete with SQL select, call stored procedure, or insert, update, delete with subqueries and so on, for those of you who are familiar with SQL, that will then make it very hard, as I explain in detail here, in order to figure out what the read set is and what the write set is and things like that. And because unlike what I showed before, where get is pure select, put and delete are pure updates, change-making things, in SQL, you can have an insert from subquery where the insert part is changing the database, but the subquery is actually doing reads. So you would have to take the insert statement and divide it up into two parts. And for the development of the read set, you would have to execute that subquery part of insert and not do the actual insert until the third phase of this three-stage processing I explained. And there are many other things like that that make it complicated. Essentially, bottom line is that in the layer between the smart contract and the database system, you would have to now have a SQL compiler, which replicates a lot of the logic that's already in the underlying DBMS. If you had to replace the couch DB or level DB that's currently being used here with DB2 or Oracle, then there is a lot more work that would have to be done on top, which is not the best place to do such things. So a better way of doing it, which I had explored in my project, was to actually make the database system itself track the read and write sets and do a far better job of it. In terms of use cases, they're all over the place. As I said before, there are many production deployments. They are by no means restricted to the financial domain. And there are some examples I have here. By the way, I didn't point out before, but if you've been paying attention, even though it's hard to see, the slides are not numbered sequentially. That's because there are a whole bunch of slides that I'm not showing you that are in the hidden state. So once you get access to the slide deck, if you see it in the slideshow mode, you'll see what I showed you, but there are other slides that you can see by going into the edit mode, which have tons more information that are that might be of interest to you and so on. So this is the Walmart one. In the food safety arena, IBM worked with Walmart in China to begin with, and also in the US, and now it's a production deployment. It's called Food Trust now, and this has resulted in, for instance, if you pick up a package in Walmart, the one that's being supported using Food Trust, previously it took that long for you to know where that thing came from. Maybe a broccoli or whatever, right? Whereas now, they are able to give it to you in this quick amount of time. Why is all this important? Because in the good old days, when there was some food poisoning or whatever, salmonella, this, that, they used to discard incredible amounts of stuff because they had no idea specifically where an egg that you picked up in one store might have originated. So it's for such reasons also, the provenance tracking that's being done is so useful. Of course, there's a cost for it. You know, whether you track individual mangoes or you track big boxes of mangoes and all that has a bearing on how much effort it is and so on. So you might want to take more trouble for more expensive things. For diamonds, for example, if I sell Gladstone a real diamond, and then he's trying to supposedly sell that to Maria, what is the guarantee that he didn't replace my legitimate diamond with a fake one and try to palm it off on her? So in order to do that, IBM has come up with a technology based on something that was originally done by a startup called Everledger, which is an attachment to a cell phone camera, which is a lens that can make microscopic measurements. Depending on the physical goods that you are managing using the blockchain, what is measured would be different. So in the case of, for instance, diamonds, it turns out there's something like the inside of the diamond which has a unique signature. Okay, they record it on the blockchain when the original thing is done. And then any subsequent persons involved in the supply chain, if they are not sure, they can then recompute that thing for whatever they were given as the real thing and check whether that matches up with what the blockchain says should be the real value. And in the case of olive oil, where there's a lot of adulteration that goes on, they measure the viscosity. For high-end cotton, they look at spectral value and so on. So this whole thing is called crypto anchor verifier. The crypto anchor being, like for human beings, we use fingerprint or iris scan and things like that. This is a way of uniquely identifying, not necessarily in a completely non-copyable fashion. There's always an element of, there's no such thing as 100% in all this. It just makes it harder, no different from currency notes having various markers and 3D logos and all that for Gucci bags and things like that. So along those lines, various things have been done because this is important to be able to manage physical goods using the blockchain, because what is in the blockchain is not the actual physical good, right? It's the digital representation of some way of describing what that physical good is. So anyway, so that's the sort of thing. It also turns out once you start tracking lots of things in a detailed way, there are various other uses you can make of the information for traceability, track and trace, transport optimization, inventory optimization, and so on. Along these lines, another project that's also in production deployment is something called TradeLens, which started out as a joint effort between IBM and the world's largest shipping company, which is Maersk. Turns out in the world trade, like that import-export scenario that I gave you before, there's a lot of inefficiency and way too many parties are involved and also extremely time-consuming, and there are still lots of paper documents and such. So it's a hugely important space in terms of money involved and all that, like 116 trillion and such. And a lot of them go across the oceans. As more and more the world economy has become intertwined with manufacturing almost always now being done in Shenzhen and places like that, even to make a car and such, there are way too many countries that get involved in various components getting transported and such. So any improvements you can make here, and by the way, this has to do with even things like a brake or a seat belt or what do you call those, crash airbags. Today, if things go wrong and it's not based on blockchain, they tend to do mass recalls, which is awfully inconvenient, expensive, waste and such. Whereas with the blockchain way of doing such things, there can be more granular, detailed tracking, what happened when, under what conditions, and this and that. And also this helps with even information dissemination and GDPR kinds of personal privacy kinds of information being tracked in a way where you know who got to see what and such things. Even fake news and so on can be handled this way. So there's a lot more here. In terms of the architecture of these sorts of systems, that is permission blockchain systems, there's a paper that appeared in 2017 Sigmod, which went into coming up with the first set of benchmarks to evaluate these systems. As part of that, they had this picture. I'm really, really sorry that it looks really bad. The top layer has to do with consensus as to what determines who gets to add a new block of transactions. There are various approaches. I briefly said, proof of work. There are variations on it called proof of stake and proof of asset and such. And then you have this Algorand algorithm that this Silvio Micali of MIT has come up with. And IBM also IBM and its partners initially used PBFT for 0.5 and 0.6 release of Fabric. But in 1.0, they said, screw it, I'm not going to deal with Byzantine faults. I'm just going to deal with only regular faults. And so they went to using Kafka as the ordering service, which is essentially a message pops up kind of system. So then there is this notion of the smart contract execution environment and the law, language and so on. The smart contracts, by definition, have certain restrictions placed on what primitives you can use. For instance, you can't look at current time and toss a coin and so on. Why? Because when the same smart contract executes in multiple places, then they'll get different results because they're not exactly synchronized in such a way that if you ask for the current time, in both places it will give the same thing, right? So there are many such restrictions that are placed in order to make the results of executions be deterministic and not probabilistic or non-deterministic. And also the language, there are differences. In the case of Ethereum, for example, they came up with this language called Solidity. Initially, Fabric supported the Go language, but now there's support for more languages like Java and so on. And also the database system that's used to track the state of the assets being managed, there are differences and they have consequences, like I said before. Get, put, delete, give me a break. In order to do a get, you need to know what the exact gobbledygook primary key is. You can't ask questions like, what are all the objects that are being managed in this blockchain? So these are, for people who are used to the power of SQL, this is all like mind-bogglingly dumb and naive and so on. And what does it have? Primary key and then a bag of bits. The interpretation of the bag of bits is left up to the application program, which in this case is smart contract. This is like even worse than pre-relational things like IMS and VSAM and ISAM, where you had primary key and then individual fields which you can name and refer to in reads as well as updates and such. So for some of us, some of this is such naivete that I'm still not happy. So don't think I'm only unhappy with permissionless. Even the permissioned, I'm unhappy with some of the silly things that have been done. In general, what I'm trying to say is that depending on which system you look at, for various architectural features, and there's a longer list here, they made different choices. And those choices have not been well documented in a way that ordinary people can figure out what they are without having to go and look at the source code and such. And also they are not well rationalized, justified, and comparisons made and say, oh, that system chose that, but we have chosen this other thing because blah, blah, blah. It leads to better performance, whatever the story is, right? So in that sense, there's scope again for lots of people to dig into these things and come up with more systematic ways of comparing them and so on. And there are some initial attempts that have been made. And I can spend, believe it or not, many hours discussing each of these bullets and trying to tell you what each system does and why I think maybe that's not the right thing to do or whatever. And a lot of these cases, I have no idea because I wasn't the developer of any of this, right? So this is the other problem. And the open source has also been taken as a license to go do whatever you want and do the minimal amount of code reviews, architecture reviews, design reviews, and documentation. Push comes to shove and you needle some guy who did something to try to explain, to ask him to explain how something works, not just the syntax, but the semantics and so on. They'll attempt it, but after a while, they'll just have this escape route which says, oh, just go look at the code, as if anyone can simply look at the code and figure out, how things work. And even if the code has comments, they won't necessarily be kept up to date as the code evolved. Bugs got fixed, new features got added, and so on. So in my opinion, as a result, a lot of the modern day things, while they are good in some ways, because as I said, apps get new versions every other day and such, they also come with a lot of baggage because I don't know when a new release of Facebook comes, what has changed. I have to by trial and error figure out and things like that. Even on more serious things than Facebook, since he cracked all those jokes about my excitement about social media. But there are many, many other things of that nature that come into the picture. So as I said before, the blockchain data structure has a lot of similarities to the traditional recovery log, but it's also got a number of differences. In the traditional recovery log, I've spent my entire life doing this kind of stuff, by the way. You write only the things that have actually changed as a transaction executed. You normally don't write what you read and so on because it's not relevant. Audit log is separate from a recovery log. Whereas here, as I told you before, in the case of the Fabric at least, they write the read set as well as the write set. So the read set is also being recorded in the blockchain. And the other thing is, of course, the careful way in which the pointers are maintained and so on, because they are trying to make it tamper-proof and such. In the good old days, as well as even today, in traditional database systems, we are not paranoid about some guy coming and taking screwdriver and fixing up the recovery log and so on. So we didn't, add hashing and such things. And also, this other point, which is like anathema to the, the hardcore blockchain crowd, which is they think forever from the time the blockchain started, the whole Ramayana, the whole history has to be maintained. This is crazy. You cannot also, when a new node comes into the network, because it's, let's say, a new supplier got qualified and becomes a supplier to IBM, you know how they initialize the new node with its state database and the blockchain? They think that it's not kosher to go and grab the state database content from somewhere else, which is what we normally do in a distributed database with replicated data when you create a new replica. Because they think since the state database is in place, updatable and all that, it doesn't have all the bells and whistles of all this protection and, tamper-proofness. They have more faith in going to one of the existing nodes and grabbing its blockchain because it's sort of checkable as to whether it's been tampered and so on. Actually, there's a slight problem even there because the guy who gives it to him could have given him a whole new one, which is, internally consistent, but it's not the reality. So unless this guy goes and gets this from multiple people and then you make all these weird statements about as long as the n number of people are not the problem, it's n minus certain number of people, the n minus people that are the problem, I can still get away with figuring out what the right thing is and so on, which we talked about earlier. We don't even know in the assumption space that people make how many failures have happened or how many people are being flaky and such. You can't even detect that. But in any case, so what they do is they grab the blockchain from somebody else and then they religiously start from the beginning of that blockchain and go through the whole reconstruction to arrive at the latest state. Essentially, the state database will be empty and then you start from time 0 and laboriously go through all this logic of which transactions committed, which didn't commit, and take the right set from the committed transactions, dump them into the database and so on. Guess what? If in fact you have high throughput in this kind of an environment, this new guy will never catch up because while he's doing all this nonsense, other transactions are executing in the system. So this is not really a viable thing in a very practical sense. And Bitcoin and all this also has this problem, by the way. And so what do we do in a traditional database system? We keep the log only for a while. As we take more backups and so on, we discard older portions of the log because they are not needed for doing restart recovery or media recovery as long as you have made enough backup copies at different points in time. There is also the other point that people don't think about, which also relates to some of the conversation we had in the morning, which is in the real world with traditional database systems, application programs could have bugs. So you might now produce a new version of an app. You already had the old version running and creating database changes and so on. The new version gets introduced. After a few days of this one going along, you now realize, oh shucks, it's got some major problems in it. It's clobbered the database by screwing up the contents of the database because of the bug. It overwrote all sorts of important stuff and so on. What do? We don't go with screwdriver, try to figure out, how to fix up this database. Normally, before we install a new version of an app, we'll take a backup of the database. And later on, if we realize that something is really, really wrong, guess what? We say, time to have amnesia. We'll go back to the state as of the start of this new version of the app, and we will forget everything that happened in between. So essentially, we will truncate the log that got added from the time the new version of the app got put in and it started making changes to the database. So this is called point-in-time recovery. We go back to an earlier point and then say, okay, now I go back to the original version of the app while some other people are going around fixing the bugs in this new version. Or if the disk drive gets messed up with the database content, then we go to a backup and then we go from the time the backup was taken in the log and we do roll forward recovery to the current time. That's the more common situation where there is no amnesia. We just have the ability. But guess what? What are these smart contracts? They are no different than traditional database applications, if you look at it in a certain way. And so they could have bugs, which could result in the state database's contents getting messed up. So just because you created some new transactions in the new version of the smart contract, if they screw up the stuff, you cannot always compensate wrongly done things because they're not really like somebody, booked a flight and later on they're compensating it by canceling the flight kind of changes. Those are more legitimate kinds of things. Here we are talking about bugs. So I have no idea what that bug did to the state of the state database or the states of some of these assets. And so people have asked for similar concepts like point-in-time recovery, which effectively says, I might forget the recent past transactions of the blockchain, which is like, ooh, this is not consistent with this philosophy of immutability and this and that people think, okay? So anyway, there are other things like, as you see here, when transactions execute, in parallel, multiple transactions will be executing and their log records will get interspersed in the order in which the changes are done. And sometimes a transaction after running for a while might roll back, in which case we write so-called compensation records. Whereas here, in the blockchain data structure, as I explained it at the beginning, the ordering service sticks one transaction at a time in a serial fashion. So there is no interspersal of multiple transactions, log records, and so on. This is a lot more geeky details, but I don't know whether anybody cares, but I don't know the bulk of the audience, what their background is. But database replication also, there are different approaches. The primary copy one is the one where transaction first executes in one place, and then its effects will get propagated. Exactly how that's done depends on the different choices I've given with different properties. In one case, the log records from the primary might get sent off to the backup, and it essentially behaves like it's doing restart recovery in a traditional database context. But that means that the configurations have to be the same, the formats and all that of the database systems have to be the same. That's not as flexible. The second one says, you use the log from the primary, and from that log you reconstruct some statements, SQL statements, let's say, and then you re-execute those statements on the backup. This means the primary could be DB2, the backup could be Oracle or even IMS and so on, in which case it won't be SQL, but some other DL1 and such. So that allows for even a subset of the database to be replicated. Whereas in the first approach, it's exactly the same, homogeneous replicated copies and so on, same code. But in order to, by the way, why is it that the third approach that some people have talked about, including that Stonebreaker, is not a great idea, where you capture the original SQL executed on the primary and you reapply that on the backup? Why is that a bad idea? This goes back to my point about non-determinism. If this original SQL has access to current time, or it accesses a rand function, tosses a coin, random number generator, when you repeat that thing in the backup, absolutely no guarantee that you'll get the same result that you got in the primary. So the in-between approach says, I don't care, whatever was the net effect of that original transaction as recorded in the log, that is going to serve as the source for figuring out in a high-level fashion what needs to be redone. So any non-determinism would have been resolved to some deterministic value that ultimately got put into the database, and it's that effect that's there. So there are lots of interesting things one can talk about this approach, because generating the SQL from the log records has its own set of interesting problems and so on, and also performance issues you have to deal with, because you don't want the things that happened in parallel in the original system all being serialized in the backup, because then you'll run into the same problem I mentioned a while ago, which is the backup might not be able to catch up with the primary if a whole lot of parallelism got applied in the main processing in the primary, but on the backup, you are now one at a time redoing things and so on. And there are also other issues with some of these sorts of things. So clearly, from all the things I've said, it should be obvious that It's not like the blockchain way of doing business is uniformly better than the traditional way because of this lower throughput and the fact that certain transactions that, for instance, in the primary copy approach, even if all the transactions conflict with one another, they would all be done serially one at a time with the primary. They would all have succeeded, and the same order would have been applied on the backup. Whereas, as I mentioned briefly before, in the fabric way of doing things in parallel initially, the simulation, conflicting transactions won't encounter any conflicts while they are being simulated. But then later on in the third step, the conflicts can result in many rollbacks. So that also causes reduction in throughput in that case. But I told you that the reason that's better in some sense is because of the fact that it involves now coordinating with different parties, whether or not they are willing to let a transaction happen and so on. And that kind of notion was not at all thought about in the original distributed database way of doing things, where they didn't really as much think about multi-party transactions and having to get approvals from multiple people and things like that. So, in other words, this kind of flow chart you will start seeing a lot these days, where people are asked to describe what their use case is trying to do, what properties they are interested in, performance, this level of trust and such things, to determine for a particular use case, is the traditional way of doing business the better one, or the modern way, which is the blockchain way. And there is no one-size-fits-all in this whole thing. There's no magic wand that you can wave to say, oh, just go with this or just go with that. You really have to do your homework with respect to the use case to come up with this. This particular chart has some bugs because they thought some European professor types that got funded by the World Economic Forum thought, oh, you can't use a blockchain if it involves managing physical goods, and that's totally wrong, as I described before. Oh my God, this is even worse with this yellow thing. This is trying to say, you have a blockchain way of doing business, but this doesn't mean you're going to throw away everything that's there that predates blockchain. In other words, each of the organizations that collectively doing something in a business process way and so on will still, when it comes to individually doing something, like you accepted an order through the blockchain way of doing business, but the actual manufacturing of that order, if it, let's say, is going to be done by just one organization, that involves, dealing with traditional database systems and app servers and packages like SAP, that gets triggered when the order arrives through the blockchain way, and then that goes and executes over there certain set of things. And once the order is ready for shipping, then an invocation is done over here to say, hey, this order state has changed from order received to order is ready to be fulfilled. And so this is the sort of thing that will happen where these things are going to be interacting with one another. And we had a similar conversation earlier today about some money being sent outside of the system and so on. So if you have a use case which is already in this chaotic traditional way of doing business, as I showed you in that import-export example, now when you want to go to this brave new way of doing things, supposedly better and so on, blockchain way, it's not like you roll in this new system called, let's say, Hyperledger Fabric, and suddenly everything will be a better world. You have work to do, because all that separately developed programs that were being executed by different participants in that workflow, they now have to figure out how to take that chaotic set of stuff and produce something that's mutually agreed upon, which codifies the rules of engagement amongst these participants and so on. In other words, this new beast called smart contract. How do you accomplish that? It's a totally different game if you didn't have anything to begin with. Now you suddenly want to start doing business. You are a new company that has come into existence. A bunch of new companies have come into life, and now you want to do a business process across them. Then life is easier. This is like starting from a clean slate that many academics would assume in many contexts. But the real world is not always as convenient. So This gives you, in a very hard to figure out way because the pictures are so messed up, how you go from the chaotic world of the past to the modern world. One approach is to make all the participants have a vote. It's like democracy. All the participants sit around the table and they agree upon what the smart contract will be and what all will be done as part of each of the blockchain transactions and such, who needs to agree on what, and that how many endorsing peers should be involved, who should be the endorsing peers for a given blockchain transaction and such. Or you say, well, some of these players are too tiny. Like, IBM and Apple might say, I don't want to go talk to gazillion suppliers that I have across the globe. This is too painful and too time-consuming, blah, blah, blah. So if you happen to have a network where both IBM and Apple are going to be nodes along with their suppliers, some of whom might be common, some of whom are not, you might say, okay, IBM and Apple alone, the big boys, are going to get together and figure out the smart contracts. And then they'll tell all these other guys, hey guys, if you still want to do business with me, guess what? You need to now install these smart contracts that we have developed jointly, and that's the only game in town. Or, as some Canadian banks did, 4 or 5 Canadian banks, that's all they have, surprisingly, in Canada. They wanted to do KYC. Guess what? They charged a startup to go figure out all this. They gave inputs to the startup, but the actual work was done by the startup. And that's one approach to take. This is like completely outsourcing to a single entity the work of coming up with the new way of doing business and so on. So there are many such things that one can talk about. This is the IBM blockchain as a service offering called IBM Blockchain Platform. It had initially a lot of restrictions. Now it's pretty flexible, meaning you can have already nodes running in different clouds, private cloud, as well as just taking a containerized version of the Hyperledger Fabric code and running it on your own machine, not even a private cloud. So then you can say, now I want to form a blockchain network across these nodes, some of which are running on IBM Cloud, some on Azure, some on AWS, some on private cloud, blah, 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 and form a blockchain network, okay? So this is one of the things that I was mentioning before, the crypto anchor verifier. These are some newer things that have happened in the recent past. In addition to what's in the open source freebie version of the Fabric, IBM, when it came out with the original IBM blockchain platform, also had certain additional features that were not in the open source version. Some of the things like developer tools and operator tools and so on. It also originally exploited the mainframe and some of the security features of the mainframe so that even the operators of the mainframe, this is another counterpoint I'd like to make to all those people who claim, oh, if you run it on the cloud, the cloud vendor has control over stuff. This is total BS because, in fact, by using these secure execution environments, even the operators of the machines can be prevented from listening in on what the data is that's being exchanged. They can't also tamper with the code that runs, not just the smart contract code, even the base platform code. The whole damn thing can be done in a very secure way. And this is true to a limited extent, not as powerful. In the case of Intel, with its Secure Execution Enclave, SGX, as it's called, they have resource limitations on how much memory and such they make available. So only the smart contracts are typically run in the secure mode. The base platform itself is run in the non-secure mode. Whereas, at least when we were running on the mainframe, we had much more powerful things to do. In any case, there's more details about this crypto anchor verifier. There's a whole issue of the IBM systems, IBM Journal of R&D that's dedicated to blockchain that came out a few months ago. And one of the chapters there is, one of the papers there is actually on the crypto anchor verifier, how even for detecting fake drugs and so on, pills and such, generic drugs and such, you can use this. Even things like barcodes, QR codes and such, to the naked eye, as well as when you use regular copiers. When you do the copying, you'll think a line is a continuous line, but in fact, when you look through the microscope, it's a discontinuous line. Even such mundane sorts of things can be used to protect, the legit thing from the illegit thing and things like that. And they can even put some microfluidics and things like this. So from a technical perspective, for even chemical engineers and so on, Raja is here. There are all sorts of great things that have been done in this space. So there's more details that I won't get into. There's also stuff that has to do with different people playing different roles in a blockchain or network. Similar to, in a database context, we used to talk about application programmer, database designer, database administrator, systems admin, and so on. New kinds of roles like that have been defined in the case of blockchain. Who develops the blockchain client application versus who develops the smart contract versus who defines the network and deals with certificates and all this, authenticating users, authorizing users, and so on. So there's a data layer, there's a business application layer, there's a presentation layer, and then on the top you see network service provider, network service consumer, business service provider, business service consumer, and end user, and so on. So this has to do with this business of not everything in this case is all just only for, in the case of permissioned, enterprise class use cases. There can be a mix of organizations as well as Joe Blow kind of users being part of this. Unlike, if you like, the permissionless one, where for the most part, for a long time, they only talked about Joe Blow sending money to Joe Blow. My sending money to one of these people here, as if that's the be-all and end-all and so on. So Caliper, I said, is the benchmarking project that was started more recently. It's still making baby steps. They're also developing some tools, not just, what do you call them? Kinds of, what's the right word? Workloads. In the case of TPC, for example, there was OLTP workload, there was OLAP workload, and later on web search workload and things like that. They are doing similar sorts of things over here. Ethereum was a generalization of Bitcoin, and the nice thing it introduced was not just this money transfer business, but doing more things with assets being managed. And it, of course, still had a lot of the bad stuff of Bitcoin in the sense of a cryptocurrency. They created their own called Ether. They also introduced the notion of this gas, which I said I wasn't too happy with. And of course, they came up with their own language called Solidity to write the contracts in. But now, IBM and its partners in the form of the Hyperledger Consortium have come up with a new implementation of the Ethereum virtual machine that's different from the original one, because the original one had some licensing terms that were not acceptable. So this is the Indie project and the Burrow project. I keep getting mixed up between these two, which has resulted in the ability to leverage all the talent that's out there, the knowledgeable people with skills in the Solidity arena, and some smart contracts that are already out there, to be leveraged in the context of Hyperledger Fabric by being able to execute on Hyperledger Fabric Solidity contracts. So this is an attempt to sort of do coexistence, that kind of thing. So we can talk about it more if you want later. So even the firm believers in Ethereum after a while said, okay, this is crazy, this whole permissionless business. We need to have a private version or the permissioned version. And that's how this whole Enterprise Ethereum Alliance got formed. And in particular, something that was developed in-house in JP Morgan, similar to what we did originally, which is the thing that ultimately got open sourced and became Fabric, and IBM caused the Hyperledger Consortium to be formed under the umbrella of the Linux Foundation and made everything that happens in the context of Fabric be open source and community developed. Originally, a private version of Ethereum was developed by JP Morgan called Quorum, and then they decided to open source it. And for a while, I thought that was going to be the only game in town in the Ethereum context. And then there was some confusion between the Enterprise Ethereum Alliance people and the JP Morgan people. They still wanted to keep this Quorum branding alive, and the people who worked on it sort of left to JP Morgan. So there was some amount of chaos for a while. We didn't know what the heck was going on. But ultimately, it seems like quorum is an individual thing of its own, and EEA is not attempting to come out with its own systems. Instead, EEA has become more of a body that will come out with specifications, and other people can implement systems that conform to those specifications. So that's the way it seems to be going, which is very different from the way the Hyperledger Consortium works. And I can go into some gory details. Maybe I shouldn't, because I think I'm running out of time, right? Yeah? Okay, so I won't get into the details, but one of the major changes that happened in the case of Fabric, going from 0.6 release to 1.0 was, in addition to the fact that the people stopped worrying about Byzantine faults and hence went from PBFT as the consensus protocol, the practical Byzantine fault tolerant algorithm, to using just Kafka. There was another major change, even more dramatic, which is the one that caused the original execution model of Fabric, which was similar in flavor to Ethereum and so on, which is all the nodes will participate in all the transactions executions. And you will first determine the order and then execute the transactions. But of course, in the case of Ethereum, it was anyone, anywhere can join willy-nilly and all that, whereas obviously in the Fabric, it was still a permissioned one and only a restricted number of people in a given network and so on. But they then went from that to, in 1.0, introducing the notion of the distinction between these different kinds of nodes, endorsing peers versus committing peers, and also introducing the notion that even within a network, just because you got admitted, it's not okay for everybody to see everything that's happening within that network. So believe it or not, this is so much more restrictive than what the original thing was in the permissionless space. The idea being, if you have Walmart and Safeway in the same network with their suppliers, Walmart doesn't want Safeway to see what all orders it's giving and how much sales it's having and so on. So it's like trade secret kind of thing. But you might say, why the heck are they all in the same network? Because they are having some common suppliers and such. You don't want to go through too much pain also in authenticating people and such things, issuing certificates and so on. So the idea was then to, like in a Venn diagram, for a given set of people, define subsets, which can be overlapping, and each subset is called a channel, in the case of version 1.0 of the Fabric. And then, for each channel, the state database, the smart contracts, and the blockchain are totally distinct. And a given transaction will run only in one of the channels. You can refer to stuff in another channel, but only read, and that's not guaranteed to be checked for in the validation phase and so on. So it's like a dirty read. So essentially, it's a single channel transaction for read and write. This other read that's permitted, ignore that for the time being. Whereas here, these guys did it totally differently. They said, across the members, there is some data that's visible to everybody, and then there are other pieces of data that are visible to only a subset, and the determination of who's able to see which subset and so on is done in a way where they still have only a single blockchain, and in the single blockchain, they only put the details of the public data. For the private data that's specific, that's visible to only a subset, they only put the hash value. And they directly exchange amongst the members of that private set the real data. So this creates major differences with the Hyperledger Fabric way of doing it, because so that's what, this is the public data that's in every node, and then you have these colored ones which are only in subset of the nodes. So the problem with this is, in some sense, is if one of these colored things gets blown up, guess what? You cannot reconstruct it by going through the blockchain, which is what we do in the case of Hyperledger Fabric, because all the gory details are there in these blockchain that's specific to that private. Whereas here, this joker has to now talk to one of the other jokers and directly get the actual data, which I said was not considered kosher traditionally in the Fabric and so on, because the database itself is not kept in a tamper-proof way. Of course, they'll say that they can somehow then compare what they get with what is in the blockchain data structure, but there's only a hash there, so it's not the same. So this single blockchain that exists in all the nodes, which contains details only for the public data and only the hash for the private data, is a totally different approach they've taken. This is the kind of thing I meant when I said, with respect to various architectural features, these different systems have chosen to do different things, and it's not always obvious what the consequences are. You can sort of know exactly what's going on, but the implication of that with respect to various things is a non-trivial extension you have to make. And so anyway, there's more details here about the evolution of the different features of the fabric and such, and I've already described some of these changes that happened, significant architectural changes from version 0.6 to 1.0. This is the difference to philosophy, for instance. In the case of before 1.0 fabric as well as Ethereum and such, you have this order the transactions, then execute the transactions, which demanded that the logic in the smart contract be all deterministic. Whereas with the newer 1.0 and subsequent versions of Fabric, you first do the execute, that simulation that I talked about, where a subset of the nodes get involved, which is also good from a performance perspective. And then you order through that ordering service, and then you validate. And during validation, you are doing very little work because you're not going through the grind of executing the smart contract. So from a performance perspective, as well as not everybody having to have a say in whether or not a transaction gets committed or aborted and so on, it's got different properties. So this is conceptually a very fundamental difference. If you want to know more about the details of all this, finally, early last year, a 22-author paper got written, which was more of a research kind of paper that describes in great detail how the fabric worked as of that time. And unlike some of the other things where there might be bits and pieces described in various blogs and white papers and such, this is really a fairly self-contained paper that gives you the technical details and rationale and all that behind this architectural difference and so on. Libra, I've already talked a little bit about it. It's a combination of a private and a public blockchain where the nodes that represent the organizations are members of the Libra Association. Their identity is known. They have to pay money to become part of it. They are the only ones who are allowed to do block creation and so on. But the edges, the clients, can be you and me kind of people, but they are kept anonymous. And this is the one that they've gotten a lot of grief about. And I still don't know the rationale behind all this. And already some of the founding members have disappeared because before their first ever meeting in somewhere, Europe, I think, a bunch of guys like MasterCard and Visa and Intuit, I think, and a few others, something Pay, whatever. Sorry? PayPal and so on dropped out. And of course, they also got beaten up by not just Trump tweeting about it, but even in Congress. One time when I agreed with, well, it's getting recorded. Okay, sorry. In contrast to some of the things I've said, a consortium of financial institutions got together and created R3 Corda. So in its conceptual model, they incorporated certain things which were specific to the financial domain, whereas the Fabric guys, in coming up with the system, had this very, let's do the basic stuff, but with pluggable componentry, and let it be applicable to all sorts of use cases, and it didn't have any built-in cryptocurrency, whereas these guys pretty much emulated the UTXO model as was originally proposed for Bitcoin and also adopted by Ethereum. And so it has, oh gosh, this is terrible. It also runs behind the firewall. Everything doesn't have to be on a cloud and so on. And also it supported relational databases. It had this notion of core vault and vault extensions and such. But more importantly, it had this notion of what has been consumed, what has not been consumed, similar in flavor to the UTXO model. And also they keep track of transaction history. They have the notion of notary. They don't really have a blockchain, it turns out. So these are more lengthy discussions one can have. But they also have notions like cash contract and bond contract. For a transaction to be declared to have succeeded or to be able to succeed, would not only have to satisfy the UTXO model kind of assumptions, but also these endpoints, the result of the execution, whatever states you produce, they have to satisfy certain things, which is similar in flavor to, for those of you who know about database systems, referential integrity or the other kind of constraints that you have in database systems, domain constraints and so on having to be satisfied. But they have this notion of notary who also notarizes, just like in the real world, some of the transactions that are happening and things like that. But it has its own set of issues compared to the fabric way of doing things or the other ones. The idea behind the Hyperledger Consortium is not to come out with a single system that's agreed upon by every member of the consortium. They actually allow for multiple projects to coexist, which actually compete with one another. So Sawtooth is a project that was initiated originally by Intel, and it took a while longer than Fabric to come out with its 1.0 version. The 1.0 in the case of Hyperledger Consortium is considered like a stamp of approval by the consortium itself as a whole, that something is ready for prime time in terms of industrial strength and so on. And this is the one that I also said leverages the secure execution features and so on. Ripple, in my opinion, precedes all this blockchain hoopla. It was originally developed as a system to allow for foreign exchange transactions across countries and such. And so it does what's called the interledger protocol, how to transfer money from one ledger to another, from one bank in one country to another bank. They also use something called JRP. What is it? XRP. That's the currency to which they convert, let's say, a real to XRP, and then they do the reverse conversion if, let's say, it's going to America, to US dollars. But since then, a variation of this in a different language called Quilt has been started as a project under the Hyperledger Consortium. Meanwhile, SAP, in a fairly recent time frame, came out with their own thing where they said, oh, we are going to make life easier for people out there who want to make some bets about the future. Remember I said you might bet on a horse and then later on discover your horse is not the winning horse and you have to rewrite your app. So they cooked up an API. Don't ask me why they think that's better than anything else under the sun. And that's the API to which if you code, then they will do the translation from that API, quote unquote, common API, to one of the APIs of the systems that they support, which could be Hyperledger Fabric, it could be Ethereum or whatever. Okay? And they're also supposed to be developing their own blockchain system. But they're also obviously members of the Hyperledger Consortium. So the idea is that you can decide fairly late that, oh, I used to use Ethereum. Now I want to switch to using Hyperledger Fabric. And you don't have to change anything because they're just going to retranslate your things to this other system's APIs. This is not an attempt like in traditional distributed databases to do heterogeneous database integration across different nodes. It's not like you have one API and then part of the blockchain transaction will run in this node and part will run in that node, and those two nodes could be running different blockchain systems. Whereas if you look at information integrator from IBM, it'll allow for you to pretend as if all the data that you're accessing is in DB2 Linux, Unix, Windows, and you issue SQL APIs as understood by DB2 LUW. And then that system in turn, the integration system, will figure out, oh, some of the tables that are pretended to be here are actually there. Some of these tables are elsewhere. And this, by the way, is DB2 on the mainframe. This is actually Oracle. And it'll take your single query and split it so that portions of the query execute in these different nodes which have your data. It might even grab the data and combine and so on. This is not that. This is just letting you go from this common API to this or that for the whole use case, okay? And they think that they are going to stay alive and that their API is powerful enough to, in some sense, combine all the features, or another way of thinking at it is the least common denominator, which might not be exciting enough. This is the standard problem with any of these sorts of systems. If that intermediate thing itself is not doing any work, is merely translating from one API to another, now you have your monkey, the monkey is on your back to decide what that intermediate thing is. Is it capable of being translated to every one of those systems? If it has some features that's supported by only one system and not another, you are in trouble. Unless you are able to make up for it in this intermediate layer, which is the sort of thing that the database information integration layers do. Anyway, this is my project that I was doing for a while, which is to replace the get, put, delete with select and all this. Give you a more powerful relational model of managing your assets, and also do things differently so that the performance and all that can be enhanced dramatically by pushing into the database system more of the functions of things like tracking read and write sets and doing validation and all that, instead of doing those things in the upper layer, which I didn't want to become like yet another SQL database system. And also there are lots of inefficiencies today in the way things are done, where in the third stage of that transaction processing, they are processing one transaction at a time, which is hyper inefficient in terms of leveraging the power of the underlying database systems. But today, of course, LevelDB and CouchDB and so on are not powerful in many ways in the sense of their ability to handle crashes and multi-step transactions and so on. They are wannabe real, fully blown database systems like DB2, Oracle, and such. So that introduces a lot of complications, and they make up for it by doing lots of other things in the Hyperledger fabric itself. So anyway, so there are many topics that need to be worked on, just like in the case of database systems, I said 35 years ago, state of affairs is what is now today for private blockchain systems or permission blockchain systems. All the great things that have happened since those days to now for relational database systems and their evolution and so on, at least some versions of those things need to happen for these systems to become more manageable, usable, easier to operate with, and performant, and being able to compare the performance characteristics and so on and so on. So even the development of the smart contract itself, ideally you would like to go from a national language description of the contract to something that's more formal looking. In the workflow management space, people used to use PTNets to represent the semantics of what's going on, and then they will do proof techniques like liveness checks and deadlock possibility and so on, and then to go from such a thing to actually executable contracts, like 4GL tools that generate SQL statements, SQL applications in the case of database applications. There are similar sorts of things that are potential areas to work in, and there are people working on lots of these sorts of things. So my SIGMOD paper that I talked about has references to some of these sorts of things, but there's a lot more that I could have referred to, but I just didn't get around to doing it. So if you want to keep track of all these sorts of things, as I keep enhancing this kind of presentation and other things, there are many social media things that you can look at. Thank you very much. I really appreciate your patience. On a Friday evening, coming and doing all this, wonderful.
Is it possible to have the presentation for the people?
Yeah, I will. Yeah, just like, once you go somewhere there, you will find me in the next few days, tweeting away or putting Facebook posts and such things.
All the time. I would like to thank you very much. It's a lot of information, a lot of ideas. It's possible that you have some weeks or some months to digest so much information. Probably all of us. É provável que a little amount of digestion. I'll turn to Portuguese for a while. Just para convidar vocês novamente, a gente vai ter o Blockchain Gov dia 3, eu não decoro, dia 3. 3 de dezembro, porque ano passado foi dia 4 de dezembro, é a segunda edição. Então, mais uma vez, convidando todos aqui para fazer as suas inscrições no site lá do BNDES, né? Acho que se você procurar Blockchain Gov BNDES, provavelmente vai cair lá, Blockchain Gov 2, né? Se eu não me engano até, né? Isso, Blockchain Gov 2. Então, e agradecer a todos aí também a presença. And thank you very, very much again, IBM, everyone, our partners, and see you in the future. Thank you very much.